Hello everyone. Today we will see the estimation of a semi-parametric pH model and it's a Cox pH model. See, in previous video we learned that the Cox pH L beta uh, is the likelihood function that we derived in previous video is the product of I1 up to k exponent of x prime j I beta divided by exponent of x prime j beta, and its j belongs to Ri risk set. And first of all, that we have to do, we have to take the e-based logarithm. Say L beta, we have ln of this L beta, so we take the ln, and after that and this L beta was this whole part, so I1 to up to k exponent of x prime, sorry, j I beta, and exponent of x prime j beta, and it has j belongs to the Ri risk set. And after that I will apply this, I will just extract this product one, and I will let this have I1 to k exp x prime ji beta, and exp of x prime j beta. See, this product was this whole part, so I just take the summation over this whole thing. Now I will apply, I extract this ln. See, ln of a divided by b is ln of a minus ln of b. That's the formula that we learned. And when I just apply this in here, I will come up with 1 to k ln of exp x prime j I beta minus ln of exp x prime j uh, beta. And you have to notice this one, this is the j belongs to the Ri, this is the summation. And after that this summation applied the whole, so you figure like this one. And 1 to up to k, and if we apply this ln, see, this thing will be at the forward. See, ln of e to the power a is nothing but a ln e, and ln e is nothing but 1, so we will come up with a. So I will here come up with this only part because it is the part is like a, so I will come up with x prime j I beta minus, I cannot apply ln here because there's a summation, j belongs to the Ri risk set. So what I have to do, I would leave it here like this one. J belongs to the Ri, and exp x prime j beta. So that is it. And now I have to take the score function. I will apply score function. You have to remember, when just estimating parameters in statistics, score function you will face a lot of the time, and is nothing but denoting u is equal to the derivative, is the first derivative with respect to the parameter of interest of this L beta. Now there is a question, this u, I cannot have this single u because I have already the p individuals. I have the p individuals, j is equal to 1 comma 2 up to p. So I have this p individual because j belongs to, refers to the jth individual or individuals from the risk set. And I will have p cross one is the order of this matrix, because this here score function is the order, or is a matrix format. So I will leave up, when I just derive this L beta, I will have multiple outcomes of the derivative. First one, u1 beta is the first derivative for individual 1. I will find this derivative for individual 2. I will have this derivative, and up to for individual r I will have this derivative, and it will go on up to p. And this whole process is too much lengthy. I cannot do it because it's a time consuming. So I will go for deriving one single one. You can do this one, you can do this one, but you have to choose the right one. The right one is the general term. I will derive this one. That is why I write this one as here. So I will have now to derive these things. Okay. Okay, it's pretty clear. Okay. Okay, now what I have, see, now I have ur beta, so I will derive this one as a del beta r of L beta. Now here r is equal to 1 to up to p, and you have to remember what was I, del beta, this L beta was nothing but this one, I is equal to 1 to up to k x prime j I beta minus ln of sum of e to the power x prime beta xj prime beta. So that was I have in previously. Now you have to be very careful in this section. See, I will derive with respect to beta r. You can see here any beta r? You'd never see. You can see only beta. And is this beta a single beta? No, it's a matrix. So you have multiple beta here. So you have beta 1, beta 2, up to beta r, up to beta p. Okay, and every beta has also its coefficient, like x coefficients x, like this part. So this is the one single representation, but here is the expanded one. So here you will have this beta r. When you derive with respect to beta r, this thing goes create value 0 and only lives with this one, and this beta r will be 1. And here is x not x, it's more generally x j I, and you will live with r in this part, because there is you derive this one. So you will have summation of 1 up to k, and you will have x j I. So what was my j? J was my individual. Individual j fails at time I. Okay, but what the individual right now? Right now the individual is r. Okay, so that is why I write an r here with this x. And this beta r is 1 because we derive with respect to beta r. And so I will have like this one here. Next, what we will have, minus, I will have minus, you have to understand this ln of something. When we derive, say d by dx of ln a. What I will have then, I will have uh, 1 by a. So something pretty much like this. Sorry, with respect to when I derive with respect to a, d by dA is equal to of ln a. I will have 1 by a as a pretty much reminder here. So I will pretty much find something like this. So I will something find here summation. So here j belongs to the Ri risk set, j belongs to the Ri risk set, exp or exponent of x prime j beta, that will I have here. And the numerator, uh, so suppose now d by dx of ln a. So first you guess this as a x, then you will have 1 by a, but this is not x, this is a, so then you have to derive this one thing with a again, right? So now I will apply at the numerator the same thing. When I just see that is some kind of single thing, but is not a single thing, it's a exponent of something. So I first write these things and I have to derive this one again. uh, when you just derive these things, e to the power something, you will have e to the power something first, x prime j uh, x prime j beta you will have, but this is not a, this is not x or something, so you have to derive this again. So when you just derive this, you will have x prime j r, because you derive this with respect to beta r, and everything else with beta r will be 0 and the beta will be 1, and you will have with a similar fashion where I did this one as, so I have this one as jr. So I leave with this part here. Next, what I will have, see, I can write it in more easy format. Summation I1 to up to k and x j I r minus, so it's a big thing, so in short I can write a, and the subscripts also needed, so I can write here I r of this beta. So next thing is so here a I r beta is nothing but this whole thing. You have to remember these things, a little knowledge would be required. Now I will take the information matrix. Okay, so taking information matrix, matrix. So I denote it like I star beta, and it is nothing but something like I rs beta. I just write in terms of the subscripts, and you can tell me what, you can now ask me a question that what is this s comes from. It's a new one, like I take the r for beta r, now it's again another one is beta s from that kind of a set also. uh, so this is what is it, and what is this irs, irs of beta, irs I star rs of beta is defined as minus del by del beta s of ur beta. So now I'm deriving this one with respect to bs, another one, another subscripts. Okay, so it's going to be again d by, so there will be a minus, so d by d beta s of this whole thing. So first of all, summation xi1 up to k, and I will have xji of ir minus, I will have this one, I expand this thing again, so I will have, so there is a little mistake, I have to give this summation, I never did that. So it's nothing but j, where j belongs to the Ri risk set. Okay, so the same thing here, summation j belongs to the Ri e of x prime j of beta, so this is nothing, into, sorry, not into it like this, x of j r, that what I have left here. So next, what I have at the denominator, j belongs to the Ri risk set, e to the power x prime j beta. So that is the thing that I am left with. Now it's going to be a big computational task. Be ready for that. See, when you just derive with respect to bs, this whole thing will be 0. So with respect to this with summation, this one will be 0. So I have to write a few lines as well for makes you comfortable. Del beta s. Now I have left with this minus comes at this could be plus, so I will left with this only this part. J belongs to the Ri e x prime j beta x j r. At the denominator, this is j belongs to the Ri e of x prime j beta, and the close brackets. Yes, this is what I have. The next, now here pretty much reminder needed. See here, now I will apply the derivative formula. Suppose d by dx of a by b, and I think you know the formula at the denominator, b square, and it will be b d by dx of a minus d by a d by dx of b. So the formula is look like this one, and we will going to apply this formula here. Okay, when you apply it here, what we will have a big line. Okay, so at the denominator, as I already mentioned, j belongs to the Ri e of x prime j beta, and this thing will be squared as by for the formula. And these things, first it will be like this one, j belongs to the Ri e of x prime j beta, and the first derivative of this thing will be like summation of j belongs to the Ri e to the power x prime j beta xjr xjs. Now there is a new term comes in because xjs, because we are just derivative taking with a new variable with respect to bs, so I will have now js again, another coefficient come from that, like previously it was. So now minus, I will have minus summation j belongs to the Ri e to the power x prime j beta x j r, and it's a little bit harder for me, summation of e to the power x prime j. Now what has happened here is that you derive the second part, and now left with the second part you derive the first part, that's this one, e to the power x prime j, and you will have this beta here. Now what we will have, um, now you can write this whole thing pretty much in simple fashion. Summation of say there's a summation I1 to up to k, this whole thing over, so I1 to up to k, and I can write it in short ways like e to the power summation e to the power x prime j beta x j r x j s, summation of j belongs to the Ri risk set e to the power x prime j beta minus summation j belongs to the R x prime j beta x j r, and summation of j belongs to R I e to the power x prime j beta into summation of j belongs to the Ri e to the power x prime j beta, summation of e to the power x prime j beta x j s. So there was, I just mistakenly doesn't include x j s like the previous ones, xjs. Okay, so now what I did here, see there is a two of them, so I take one and this two, dividing in these two single parts, and I write this part as here, because there's a two part of this, so this two here will be squared, and there also squared. If you multiply this you will get this thing, but here is a single one I written because one was cancelled with this part, so I will left with this part. Okay, so I cancel one and I give it here one, but I have two of this and I have two of this, and I equally distributed them. Okay, why I did this? Because I wanted to write it in short terms, like summation I1 up to k. Here you will have AIR is beta minus AIR beta into AIS beta. I just write in with A, just make it comfortable and shorter. Okay, because this part represent this part, this part represent this part, and this part represent this part. Okay, so now there is a question, there is a very important note to be noticed. uh, if you see this AIRS, this part, if you notice this part, you will have something, some interesting facts. There is the one, and this is the one, and this is the one. In these two things are equal. Because of why? Because these two things are nothing but the cross product over the risk set Ri, and this is the weight. So this is the weight. If you ever done the weighted mean, then it is nothing but the same thing here has done, but it is not for a single one. It is xjr and xjs, and that is why I'm saying that this is a cross product of weighted mean, weighted average here is performing here. And the weight, what is the weight? Weight is this part. Okay, so that is the thing to be noted here. So now, using the partial likelihood equation, for that I take u beta is 0, and using Newton Raphson method, iterative process, iteratively, I can estimate the parameter beta hat. How? For example, beta hat is equal of m, is equal to beta hat m minus 1 plus I star beta hat, and this thing will be inverse with u beta. Okay, and this u beta was derivative b is equal to b hat m minus 1. Same thing is here, b is equal to b hat m minus 1. This is the Newton-Raphson method. You already see something like this x. If I just give you a insider, x of what you can say, x x of n, you can say that, then it will be x n minus 1, and plus you will have x, or f of x, f of prime of x. So here this f of x is nothing but u of beta. Okay, and f prime x is nothing but I star of beta. So this thing is this thing, and this one is that. Okay, so it comes from the Newton-Raphson method, and we can easily estimate the parameters using this one. So now there's an important factor. Beta hat can be normal for a multivariate normal, p-variate, as it is a p-variate. So beta, then it will be parameter beta I star minus beta, because it comes from the properties of normal distribution. And when it will be normal, when n belongs n tends to infinity. Okay, and you can also take the marginal distribution of beta r hat, like beta hat r belongs to normal, beta r comma I rr beta, as n tends to infinity. So that is the estimation process of a semi-parametric pH model. Thank you very much.